All right, guys, welcome back. So this is the new motor. Here's my hand. So here's the size of it. And these are the magnets that are going to be on the end of it. These are N52s. These are some powerful magnets. And so there's going to be 8 of them all the way around. And right now I'm printing end caps to go on each end to hold the magnet in place. Even though this is really tight, it's not going anywhere. I do all my stuff, like I said, press fit. And then I made these inserts that are going to go in there, and then a rod's going to go through, and the bearings will be in the stand instead of in the rotor itself, which I think will help maintain its centricity, if you will, or its vertical axis. But yeah, so I haven't decided whether I was going to drill little holes. Which side is it? Oh, it's this side. Drill little holes and put some brass screws in there, because this is really tight. But I think, given these are N52s, they're I think they're like 2 inches or 50 millimeters, and they're really powerful. But anyway, I'll get it going. I'm printing, like I said, out the end caps. I'll get it in the stand and we'll take a look and see how it's gonna go. Stay tuned. So here's the end cap I'm printing out. I always print out one as a test. And I always, if I'm putting something over something, I give it 2/10 of a millimeter larger. If I'm going smaller, I do 2/10 smaller. And that seems to work almost every single time, at least with my printer. I guess each person has to decide what's good for their printer, what their tolerances are. For me, it's like 2/10 of a millimeter. I don't know if that's good or bad, and you really can't see what I'm printing, but they are the end caps. There we go. It's a little blurry. Sorry about that. Doing this with my Samsung. I think this is an S. This is a Galaxy 9. I don't know. All right, stay tuned. I'll show it to you when it's done. All right, so I opted to put the screws in, and I'm glad I did, because it wasn't coming apart, but just to be safe, because again, I'm using those N52 magnets, and they've got quite a pull. And even if this cap did come off, these would not come out. And it kind of looks good. And now I'm going to put it in this stand, and then I'll put the magnets in it one at a time. And I printed out the caps. What did I do with them? Oh yeah, here they are right there. I printed out the caps. There's the rod. And the rod's going to go through here, and I got to find the other cap for this end here, because I 3D printed caps for all of these captive bearings. I've got 2 bearings per side. So let me find those caps and get this thing mounted, and I'll bring you guys back. So I couldn't find my bearing covers, but I have these collets, and they'll hold everything in place. And it's going to be a big ass rotor, and it spins beautifully. Wow, I'm just noticing that rod looks like it's a little bit bent on this end here. It doesn't seem to affect the rotor though, unless that's just, I think it's just deformed right here. Probably from me whacking on it. This is stainless steel too, non-magnetic. All right, I think it's 304. Actually, it's supposed to be 304. It is very, very mildly magnetic, not like this guy, which is a pure 304, non-magnetic. All right, yeah, it's so big I can't even get it fully into the into the, what you call it. So let me get the magnets on there and go from there. Stay tuned. Excuse me. So as I was putting the magnets on, I put the first one on. I was thinking, because normally what I do is these are magnetic along the, I forget what it's called, but this side is north and this side is south. That's how I normally do it: north, south, so forth and so on. But I was thinking maybe I should turn it 90 degrees and have the north up here and the south down here all the way around, which would give me a lot more poles, but I don't think that would be good because they're not close enough together to become super poles. So I think I'm going to stick with the north, south facing outwards. Yeah, stay tuned. So I did not like that stainless steel rod. It was bent. It was definitely bent. So I put a carbon fiber tube in there, and it's much straighter. Even there's no more wobble, because I built this pretty good. And I've got a magnet on either side now just to see how it's balanced, and it seems to be pretty good. And I still use the same collets on the end because I don't know what the hell I did with my caps. And they were press fit caps too, but the collet's good for safety. Let's see. Let's put it halfway like that. Yeah, that's pretty good. I've got two magnets on either side, so the balance is good. So let me get the rest of the magnets on. Yeah, this rod was pissing me off. It was, even though it's probably straight most of it, it definitely caused this guy to wobble a lot, and did not like that. Stay tuned. So there it is with all the magnets on it. And the little end caps. You can see the little end caps kind of hold it on. I mean, they're not going anywhere. Everything is a press fit, even though I put those screws in there. But I just thought it looked better. Yeah, and then I'm going to use this big ass bifilar coil with the new bifilar JL94 circuit. This guy right here. I want to get it a little bit closer though, so I need to either print out a stand or just put something underneath there. I'll figure it out. Stay tuned. So I was trying to, it's running great, you can see. Only one of the sides is hooked up because on this particular bifilar coil, it's wound differently, where you can't use the second circuit to help run this particular rotor, because that second one is set up as a pickup coil. So I think it's wound differently. I'm not really sure. It's running good though, especially just for one side. Everything's nice and cool. I'm kind of staying out of the way, even though I don't think it's spinning fast enough where it could throw any magnets. Let me turn it off. Because like I said, I've got this thing pretty secured. Let me slow it down here. Come on. Yeah, these are N52s, so they're pretty powerful, but it's balanced really nice. which is really cool. But I've got to get the other coil in there, the one that's actually meant for this type of circuit. Then we can really get this thing flying. Stay tuned. All right, there it goes. That's a big, big rotor. And I know I'm using that coil incorrectly. That should be for my Maglev, which I will do next. But I just wanted to see how it works with this guy. And I'm getting really good output. That's a great coil. I do have a significant wobble, and that's because I chose to use inserts in the rotor housing instead of bearings, but it would have wobbled anyway because I had to print it with supports, and the supports don't all come out right, and so it makes it so it's not completely flat, but it's still working pretty good. That is one big ass rotor. Makes a weird sound too. I don't know what that sound is coming from. That's at 12 volts. All right, I also have another coil which I want to try, which is really interesting because this coil has iron in it. So I think between each of the pancake windings, there is a layer of iron, which makes the coil slightly magnetic, which should give me a higher output. I can't even get the whole thing in. There we go. Here, let me come back over here. All right, let me switch it up and bring you guys back. Stay tuned. So, yeah, that one's putting out a higher output. I don't have it close enough to the, oops. I must have a wire that's not seated properly. It's not close enough to the rotor yet. Oh, I think I know what happened. The positive and negative touched. So if I lift it up like this, I mean, I can feel it pulling on the magnet. I know this is a janky setup, but the closer I pull it to it, the faster it goes. It's starting to really fly now, giving me a solid output. Yeah. You can hear it too. Yeah, it's starting to really fly now. Yeah, I've got to build a mount for it so that probably drill some holes here and some holes here so I can run the wires through there. But yeah, I just wanted to give it a try. Stay tuned because I'm going to set up the Maglev with that curved coil. Stay tuned. So when I went to run it for the first time, it ran great, but it made a lot of noise because it wasn't spinning freely. Now it's spinning freely. And I put some dry lube on the ends there. So hopefully the next time I bring you guys back, it'll be humming like it used to. Maybe I should get these guys out of here. Does it actually feel that? See that guy right there? Oh yeah, it is. I got to get him out of there. Yeah, look at that. It's interacting. These are strong magnets. These are N42s. I think these are N45s. those are N52s. Those are scary strong. These are scary strong too, but yeah, I got to get them out of there. They're too close. All right, stay tuned. Now it's going nice. I want to try this coil with a Hall circuit. Yeah, that's nice. Getting solid output. I'm not even that close. I can't get too close because I had to put a piece of plexiglass in there to hold the coil up properly. You can see it, and I put a piece of soft foam on there not to hurt the coil. Pull it away, it goes a little faster, a little smoother too. Yeah, it's still making a little bit of a rattle. So it was going much smoother earlier. It's running perfectly true. It's making a lot of noise. Let me see if I can. Can I do to alleviate that noise? I think it's just because my setup is so, I've got stuff on the table here that's vibrating. Got this big old 304 stainless steel thing here. I don't know what I got that for. Oh, that's right. I found this. Yeah. Talk about a find. Look at this thing. That's worth a lot of money, man. That's 304. That's non-magnetic stainless steel. Oh, it's this side here. I think I have to I have to take away a couple of spacers to push it out this way a little bit. Here, let's fire it up again and see what happens. There it goes. Nice, solid output, even on the camera as well. It's in person, it's completely solid. That's a great coil. Let's see how far away I can pull it and still have it. Yeah, I want to try. Let me turn this up. I want to try the Hall circuit on this with this coil. I think what I'd have to do though is jump the coil to turn it into one solid coil, or I can just use one side. But I want to try a Hall sensor on here now that I've got this. But what I need to do is I need to figure out I think I know what the problem is on that end. It's pushing too far in that way. If you look at this, if you look at this, you see where the magnet is in relationship to this outer ring magnet versus this guy. Maybe you can't tell, but I can tell. It's like one washer in, and it's not spinning as freely as it used to. All right, let me play around with this and I'll bring you guys back. Stay tuned. So those of you who don't know the mechanics or the workings of a maglev, it's a balancing act between the rotor shaft bearing and the rotor shaft magnet and the ring magnet here. The farther away the back plate is, the more secure it is, because once you get it past a certain point, it pulls it up against the back wall there. You don't want it to pull too hard, because then it will push too hard against the back plate here, the stainless steel plate, and cause it to bog down. At the same time, you don't want it too far this way, because then it's really hard to even get this guy in there if you don't have some help from the magnet pulling it and touching the back wall. So it's a balancing act, and it's a real pain in the ass, actually. But yeah, it's a balancing act. So basically what I did was, I have this separation between the back plate that has the stainless steel back plate on it and the housing that holds the larger ring magnets. And to adjust it, you put spacers in here, in this case, washers. And I have them on both ends. And ideally, you want it to just be sitting and pressing against one and floating on the other side. So it's not being pulled too hard in either direction. That's the goal, is to get it to only push on one side, but not too hard, and then have it just float on the other side. So hopefully what I just did will help. So I'll let you know in a second. I'll bring you back. Stay tuned. Whew. And once you get it in there, if it spins freely like this, then you're okay. And you can actually see that you should be able to hear it click, click, click. But as long as it's spinning freely, that's okay. Oh, what a pain that was. I also have to make sure that it's at a 90-degree to the shaft. All right, let me get the coil set up, and we'll see how we did. Stay tuned. We wanted to get to that nice hum like that, but not that rattle though. There we go. There we go. She's flying. Solid output. This side really rattles a lot. I don't know what it is, but then it gets into a nice hum. Let me turn it off, because I want to try a couple of other coils. See, I think I need to change. Yeah, I think I need to change. I think I need to turn the back plate around. Yeah, stay tuned. So this coil does not like to be jumped like this to make one, because normally when I put a coil there and I have to find the right spot for the Hall sensor. Yeah, I'm gonna try, instead of jumping it, I'm just gonna try one side and see how that works. I mean, it works, but not very good. Stay tuned. Yeah, it works much better with just using one side. Not really, it's kind of the same. Much better output just doing one side. It does not like that. It wants to be down. No, stay away from me, will you? Jeez. It wants to get sucked into the rotor. No, it doesn't like that. All right, so this coil does not like to play with a Hall sensor. I mean, it's okay. Let me try the other side. Stay tuned. I'm going to switch and see if the other side is any different. About the same, but that time it auto started. The other times it didn't. Let me see if I push it in a little closer. Getting good output. So yeah, they're basically, and I think they're the same gauge wire, so they're basically the same. It runs good. There's nothing wrong with it. Pull it back a little. Let's push it really close and see what happens. Nothing. All right. It runs nice and true. It's a lot of noise, but again, I think that has a lot to do with all this crap on the table. I really need to clean up this shop, man. All right, I want to try that other coil, that big-ass magnetic coil. I mean, the one that has the iron in it. I want to try that one on here with the Hall sensor. Stay tuned. So it likes this coil. I'm getting massive output. When I say I'm getting good output, I can tell by the light on how bright it is and how steady it is. The camera doesn't, the camera shows it flashing. And this is a different Hall circuit. I should try different circuits. Trying to see where the noise is coming from. There it goes. All right. I just wanted to try that out. Let me turn it off. It's actually getting sucked into the magnet because of the iron. Yeah, it's not really getting, it's slowly getting pulled into the rotor because there's iron in between. All right. Yeah, I need to fix this guy. I think it dug a small hole in the back plate of the stainless steel. Not really deep, but deep enough to make it wobble a little bit. All right. What else am I going to do today? All right, stay tuned. So that's my coil, the one that I did a little while ago. There it goes. Let me turn it off. So if I get the Hall sensor just in the right place, this thing hums really nice. But I think I need to change these guys out because it looks like looks like the stainless steel might even be a little bit bent. I don't think so. I think it's these guys here. Anyway, what I want to do next is I want to build a smaller, more stable rotor so that I can do some real testing with some output. enough with these crazy ass giant rotors and carousel rotors and solenoid. Actually, I want to get that solenoid out here and set it up with the bifilar JL94 and see how it runs on that. Run two of the outer coils, the two side coils. I want to definitely do that, but I want to build a smaller, more stable rotor, just a small 4-pole thing to try a few things out. But I can't 3D print that because I want to get it up to high speeds. And the 3D printing is fine for farting around, but when I start wanting to get up to really high speeds, so what I'm going to do is I'm going to use the VCR motor, and I think I have another old VCR somewhere. I'm going to use the VCR motor, and then I'm going to have to get an aluminum housing to attach to it. I can probably do some 3D printing for it, but not if I want to do high speed. Anyway, thanks for watching. All right, so I couldn't help myself. I had to set up the dual JL94 circuit on the solenoid motor. Let's see how we do. Oh yeah, it flies. Really good output too. Louder than shit. Because this, yeah, working out really good. So there's, in this tube, there's, I think, 25 magnets that are about a 1/2 inch by 1/2 inch. And they're all going in one direction. So north, south, north, south, north, south, all the way around. And I haven't played with this for a while. My buddy from down under designed the very first one, which was to be geared. And then over 6 months to a year, he and I worked on it together to refine it, and we changed it to rollers. And you can see the rollers in there, and there's really not a lot of play, but because it's plastic roller on plastic roller, you can see down there, there's a little bit of play. Yeah, there's a little bit of slop in there, which is why it makes all that noise. What I want to do is, and I had started this a little while ago, was to take it apart and put bigger coils on here. But it does work really well with this JL94 circuit. Works really well. I love this circuit. This circuit makes everything work twice as well. I love this motor too. It's my favorite motor that I built. All right, guys and gals and everybody, thanks for watching. Ciao. You know, really quick, I was thinking, I wonder if I put some dry lube on the rollers, because the rollers are installed with bearings on them, which is why it spins so nice and free. And of course, the weight of the ring itself acts like a flywheel. because this ring is heavy because it has a lot of magnets in it. But I'm wondering if that is kind of loose in there, though. I'm wondering what's wrong with that one. No, they're all like that. But I wonder if I put a little dry lube in between. It won't stop the noise, but it will speed it up. Yeah, I think I'm going to play with this guy for a while. Unfortunately, I can't. I have the original files, but they've been modified and changed so many times that, and I think I printed out the correct ones to replace these guys because I want to wind bigger coils, larger coils, different connectors. I think I'm going to work on that next. Yeah. Cool. Stay tuned. Yeah, a little dry lube definitely speeded it up because it's flying now. And I did find ooh, that dry lube stinks. 12 volts exactly. He's flying now. That's as fast as it's ever gone. Probably because of the circuit and the dry lube. All right. Peace out.